All right. So, like I said, we're going to be focused on inequalities today, and we'll look first at absolute value inequalities. So, solving So, so of course, jumping into what we're jumping into today with inequalities, right? We're kind of assuming you can already solve normal inequalities and stuff like that, right? And what I mean by normal is just like, a typical kind of algebraic stuff with x's on both sides. You get the x's to one side and solve and stuff like that, right? With inequalities, right, we want to be careful too because inequalities have that kind of extra property from equations where if you divide both sides by a negative number in an equation, no problem. But in an inequality, if you divide both sides by a negative or multiply both sides by a negative, right, that inequality sign flips because the value kind of flips. Okay, and so you want to account for that kind of thing. All right, so we're going to kind of skip over that, assuming you can kind of do those without much trouble, and then we'll jump into the instead something that's more akin to or a little more tricky, right, a little bit different of an idea. Okay, so let's see. Got it here somewhere, maybe. There we go. Okay. So we'll first talk about, like I said, these absolute value inequalities. Okay. So before we talk about the inequalities, though, it's helpful to remember what it means by absolute value, what we mean when we say absolute value. Okay. What does absolute value mean? So, yeah.
Distance from zero.
Perfect, exactly right. Okay. So, a lot of us have this idea in our mind about the absolute value being just, it makes things positive. Which is right, that is what it does, but why does it make things positive? Because the real definition for absolute value is distance from zero. Okay, you can think like on a number line if you want to. Okay, so that now we see, aha, this is why things are positive, right? A distance won't be negative. You're always, measuring that. So from zero there, whether it's in the positive direction or the negative direction, the distance will still be a positive value. So with that being said, right, that then makes sense when we see things like the absolute value of x equals 3. Okay, that means you're trying to find numbers in here whose distance from 0 is 3. Okay, well, what numbers are 3 units away from 0 on a number line? -3 and 3, right? And so that's why we end up with both 3 and -3 here, or what you might see, x equals plus or minus 3, right? Whatever way you want to write that, okay? But that's where that idea comes from. Absolute value means distance from 0. Okay? So, if we see something like the absolute value of x is greater than 3, that means we want the distance of this thing, the x, be greater than 3 units away from 0. Now let me draw a little picture here on a number line, right? This is probably going to go like way back to elementary school or something like that here, but please forgive me if I'm insulting you here, but okay. So of course 3 and -3, we already established 3 and -3 are exactly 3 units away, but if we want to go greater than 3 units away, well that means here again 3 is 3 units away from 0. If we want to go more than that, do we want to go further to the right or further to the left? If we want to go greater than a distance of 3 from 0, we want to go which way? To the left or right? To the right, right? These are values that are greater than 3 away. So this means we want to go x greater than 3. Okay? But simultaneously to that, right, a distance of 3 away from 0 in this direction means we're going to start here at negative 3 and then go, what's further than 3 units away from 0 this direction? We want to go which direction here? To the left, right? And so that would be x less than negative 3. Okay? And so a graph of this, well, we're not going to include 3 because 3, it's not equal to there. It's right greater than 3. So 3 is exactly 3 away from 0. We want to be more than that. So we'll not include the 3. And we'll kind of sketch this way with a little arrow there. And then, again, sketch this way with a little arrow there like that. Okay, so there would be like a little graph there. Okay? Now this is a compound inequality, right? And the compound, it's an OR compound inequality. Or we have to have two separate inequalities here. We can't put these two together. They don't overlap, right? They're separate inequalities there. Okay, they might overlap, but in this case they're not going to overlap. Okay? It's an OR inequality. Okay? So this, you may remember this maybe from doing these in the past, right? You're like, Mr. Wade, I remember like we kept one and then we flipped the sign and then, or flipped the sign here and flipped the sign here and made it work. But that's why we are doing that, okay? Because we want to be greater than 3 away. So we go more than 3 away, but less than negative 3 away to kind of get that distance to be greater than 3, okay? Like that. Okay? If you need help remembering this, right, this is the greater than symbol. And so one way you can maybe remember this is great or than. No? Okay. Well, anyway, there's someone, maybe it'll help somebody. Okay? So, next one. What if we had it, absolute value of x is less than or equal to 1? Okay? Less than or equal to 1. So now on our number line, we'll again have 0 in the middle there, put a 1 here and a negative 1 here. Off the screen. There we go. Alrighty. Well, now we want the distance of this thing to be less than or equal to. Less than or equal to 1. So again, if I go 1 away, am I less than or equal to 1 away from 0 at this point? Yes? No? Yes, right? We're less than or equal to 1. This is exactly 1 unit away, so we are less than or equal to 1. So we're going to include this point. And then from here, if I want to go less than or equal to 1 away from 0, which way should we go? To the left here, towards lower values, because we want to be less than 1 away. So we're going to go in this way, right? But simultaneously to that, right, if we go over to here, the furthest away we can go is to negative 1, because that's 1 unit away from 0. Okay? But to be less than 1 unit away from 0, am I going to go to the left of this or to the right of this? To the right. And so it's what's between there. Right? Okay. And so some of you might have seen this in this way before, right? You could also write it as this. X is greater than or equal to negative 1, and x is less than or equal to positive 1. Okay? And again, you see kind of like a similar behavior happening here, where we take the inequality, just drop the absolute values, and that's one of our inequalities. And then we take the inequality, flip the sign, and flip the number here. Okay, and that's the other inequality that we solve. But one's an OR for the greater than, right? It's OR because we're kind of going to go opposite directions from each other. And then this one right here is an AND. And you can remember this maybe with the less than to help you remember that. Okay, so this is an OR inequality. This is an AND compound inequality. All right, but that's the idea there to help you on that. All right, questions on any of that? Okay, so let's see this in practice here. So let me do something like, I don't know, 2 absolute value of x plus 3. Let me see here. 8. Let's do something like this. 2 times the absolute value of x plus 3 minus 7 is less than or equal to 1? Yeah. Is less than or equal to 1. Okay. In this situation, right, we've got some other stuff going on with our absolute value inequality here, besides just the absolute value itself of x plus 3. Okay? So here we've got the absolute value of x. These are all kind of isolated. So what you want to do here first, okay, is isolate or solve for the absolute value. Okay, you want to isolate that absolute value. So we'll solve for the absolute value. So we'll add 7 to both sides here. Divide both sides by 2. Oops. Like that. Okay. And now we have that absolute value isolated, we can use this concept, okay, that Kemi was talking about earlier, where, again, the distance of this thing, we want it to be less than or equal to 2 away. So that means we want x plus 3 to be less than or equal to 2 away. We also want x plus 3 to be greater than or equal to negative 2. Okay, because, again, on that number line, right, we want this thing to be less than 2 away. So it's going to be between negative 2 and 2, like that. So, oh, did I make a mistake? I can't, yeah, division. Well, good. I'm glad you guys at least, pointed that out. Okay. This is bad enough without me inventing new math, right? So, all right, there you go. Sorry, should be 4 because we divide both sides by 2 there. Okay, so yes, so we'll finish solving here. So we'll get x is greater than or equal to negative 7, and x is less than or equal to 1. Right? Okay. And again, this is an and inequality here. And inequality. Okay. If you like to, right, you could have done this as a compound inequality, negative 4, or a combined kind of compound inequality there. Like so. Okay, we have negative 4 less than or equal to x plus 3 less than or equal to 4, and then you could subtract 3 on all the sides there and get it this way instead. Okay. But they both mean the same thing. Okay. So our solutions then are between negative 7 and 1, right? And again, if you wanted to graph here, I'm not going to do a very detailed graph. Solid dot because we're equal to, right? And then shade between. Okay. All righty. Questions on any of that? Ready to try one on your own? I'll take that as a yes. All right, so try this one here. Again, I'm going to say solve/graph the solutions on number line, right? Okay, and I'll just give you a 1. Maybe I'll give you 2. So absolute value 2x plus 3 is greater than or equal to 7. Okay. So that'll be that one to try. And then number 2. Absolute value of x squared minus, I don't know, 2x cubed plus x to the 5th is greater than, actually let me do it this way, is less than negative 2. Okay, so those two, give them a try. Just really haven't seen one with x squared or x cubed or x to the 5th in it yet. How can you expect us to do this? Well, you can do this one actually. You can figure out the answer to this. Anyone still need more time? Yeah, okay. Take a little bit longer. So will grouping be a strategy we can use here? Okay, so I think is anyone still working on number 1? Nope, okay, so let's go over number 1 here at least, and then we'll see what we can try and figure out for number 2 there. All right, Megan Chang, what do you say there for number 1?
Do you want how I did it or the answers?
I will, let's see how you did it here. What's the next step, I guess I should say that, right? What's the next step?
So I broke it up to 2x plus 3 is greater than or equal to 7.
Okay.
And then 2x plus 3 is less than or equal to negative 7.
Okay, exactly right. Again, we want to be more than 7 away, so that means we want to be greater than or equal to 7, but also to be more than 7 away, you could go less than or equal to negative 7, right? Okay, so then you just solve these, I'm guessing. Okay, and what did you get for this one here when you solved it?
I got x is greater than or equal to 2.
2, okay, and then what about this one?
X is less than or equal to negative 5.
-5, okay? So, we're going to go, and again, this is an or, right? Great or than or equal to, so it's an or inequality, so we're going to go in opposite directions here, or at least, greater than or equal to 2, so it's going to look something like equal to, so put a point, and then we, like that. All right, and then -5, solid dot, and then like that. Okay? And so there's our solution set. Okay? And of course, why do we bother graphing this? Because this, shows visually the solution set for this inequality. Yes?
How did you get the 5 going the other way?
How to get this right here?
-5 going the other way, yeah.
This right here?
I got both of mine going right.
Okay. So, so you're okay with this one?
Yeah.
Okay, so let's go back to the idea here, right, on our number line. Okay, if I want to be greater than 7 away, I can go 7 in the positive direction, right, and then more than that, so greater than or equal to 7, right, I'm going to go this way. But I can also go 7 in the negative direction. But in this case, I don't want to be greater than -7, because if I go greater than -7, I'm going now in towards 0, which is not more than 7 away, it's like less than 7 away. So I need to go less than -7 away. So when I set up the inequality here, it's got to be less than or equal to the -7. Not a greater than or equal to -7 there.
Oh, okay.
Do you see it now? Yes? Okay. So right, the greater than or equal to for 7, right, for the positive direction, no problem. But then because we're going in the negative direction, I have to be less than or equal to -7 for going in the negative direction. You're good now? Okay, cool. Good. Other questions on that? Okay, let's go to then, I'm ready to talk to that person. Let's go here to Zoe Starr. Zoe Starr, what do you say for number 2?
I didn't get that one.
You weren't able to solve it?
No.
Good, because the answer is no solution. Sure. Someone want to explain that for us? Megan Chang, go for it.
Because the absolute value of a number is always positive, so it can't be less than a negative number.
That's right. Yes, Sydney.
Okay, well, if it wasn't no solution, can you factor out x's from like an absolute value thing?
Sure. Sure.
So can you show us how to do that if it wasn't
Bless you.
negative?
Show how to do it if it wasn't. Oh, if it was like a positive 2, you're saying?
Yeah. I just have like
Yes.
Should be on the next assessment.
Let me think about that. What's that?
Is this gonna be on like the next
No.
assessment?
I gave this to you because that was the case.
Then I don't think-
Right. So sometimes, right, yeah, in this case, well, yeah. That's all there is to it. Okay? No solution. There is no solution to this one. We don't have to worry about that. As far as solving this, if it was like greater than Negative 2? Oh, well, actually, let's just, okay, let's do that here real quick. So the question was posed, okay, Mr. Wade, can you show us how to solve this, though, if it's this? What would be the answer here? And the answer is not no solution. Don't ever think it too much. We're going to use the same, similar kind of like reasoning from what Megan said for number 2. So yes, Kat?
I'm like unsure, but could you like add 2 to the other side? Like if you like
Could.
broke it up and then like added 2.
Yeah, if you wanted to. Yep, we can do that, right? It is an inequality. We're allowed to add the same thing to both sides. This might help people see it. So it would look like this. So we're going to take the absolute value of this, add 2 to it, and we want it to be greater than 0. So what are the x values here that would make this inequality true? Any real number! Exactly right. All solutions will work here. What? Well, it's the same kind of reasoning that Megan said earlier, right? The absolute value of something is always positive. A positive number is always greater than negative 2. So no matter what you plug in for x here, you're going to take the absolute value of it, and it's always going to be greater than negative 2. So it's all values for x there that make that true. All right. That's exactly right. Okay. Mr. Wid, stupid tricks. It's not real math. Maybe. Okay. Sometimes we get so involved in like the details, right? We can't see the forest for the trees, and we're like, oh man, that was a lot easier than I thought it was going to be. All right, oops. Now we're going to take a look at solving polynomial inequalities. Okay, so shifting gears from absolute values to polynomials. I hope I spelled that right. Yes, that looks good. Handwriting might be not so good, but anyway. Okay. And we're going to mainly stay on quadratic inequalities, but if you can do a quadratic, you can really do any polynomial that factors, that is, after that. Okay? So, example. Okay, so 2x squared plus 5x is greater than 12. Okay. So just like we saw the polynomial equation, we're going to use the zero product property again here. So the first thing we want to do is solve for 0. Okay, so solve for 0. So that means we'll subtract the 12 over. We'll get 2x squared plus 5x minus 12 is greater than 0. Okay. Again, same kind of scenario we did, or same situation we did before. We'll factor as well. Okay, so we'll factor. All right, so let's see, this is going to be 2x and an x. And then what are our other numbers going to be here? How does it factor to be 2x minus 3 and x plus 4? Very good. Exactly right. Okay, so it does factor nicely. Thank goodness. Okay. And then we're going to go an additional step here, and we're going to solve for the zeros. Okay, so we're going to like, not assume, but we're going to kind of like take the idea, oh, this is an equation. So we'll say 2x minus 3 equals 0, x plus 4 equals 0. Okay, and so we get x equals 3 halves, and x equals negative 4. Okay. Now we're going to graph the zeros on a number line. Right? Because ultimately we want to be able to graph our solution set here. We want to be able to kind of like, graph our solution set. So on a number line here, we'll put 3 halves, and a negative 4. So this is going to be negative 4, right? Because that's less than 3 halves. Okay. Negative 4 and 3 halves make our inequality 0. Should we include these as part of our solution set? Parker, you're shaking your head no. Why not?
Because it's not equal to 0.
Right, our inequality here is not equal to 0. It's got to be greater than 0. So we won't include them. How do we show we don't include them? Open circle, right. Oh. Okay. So why do we bother graphing something that we're not really supposed to graph, right? Well, this divides our number line up into 3 intervals, right? 1, 2, 3. And it's a matter then of just testing which intervals work. Testing just which intervals work. So what I mean by that is we're going to pick an x value here, okay? Test intervals in the inequality. Okay, so pick any number you want here in that interval. Say, what? In this first interval here, what can we pick? Negative 5, great choice. Let's plug negative 5 then into our inequality here. Now you can plug it into any part of this inequality. You can plug it in up here, and you want to check to see if it's greater than 12. You can plug it in here and check to see if it's greater than 0, or you can plug it in here and check to see if it's greater than 0. I'll just plug it in the factored version right here. So negative 5, I'll do this one more explicitly here since we're just doing this for the first time. So 2 times negative 5 minus 3, and then negative 5 plus 4. Okay? 2 times negative 5 is negative 10, minus 3 is negative 13. Negative 5 plus 4 is negative 1. Negative 13 times negative 1 is positive 13. So this interval is positive. Okay, this interval has a positive 13 in it. Is that greater than 0? Yes. And so that means this is part of our solution. Okay. All those numbers in that interval will be part of our solution. You only have to check one. As long as you found it at zeros. All right, let's pick a number in here to check. What will be a good number to pick? 0, of course. Yes. All right, now, here's the thing, right? We're only interested to see if this quantity is greater than 0. Or in other words, we're only interested to see if this quantity is positive, right? Because greater than 0 means positive. So all I need to do is just check here. If I plug a 0 in, I'm going to get a negative value, right? 0 times 2 is 0, minus 3 is negative. Plug in 0 here. 0 plus 4 is positive. A negative times a positive will be negative. And so is that greater than 0? No. So that's not going to be part of our solution interval. Okay. And then 3 halves, let's pick 2, right? So again, let's try 2. 2 times 2 is 4. Minus 3 is going to be positive. 2 plus 4 is 6, which is positive. Positive times a positive is positive. Is that greater than 0? Yes. Okay. Mr. Wood, come on. Do we really have to do that? I mean, these are just going to alternate, right? If I figure out one, I can just be like, well, then the next one's going to be the opposite, and the one after that will be the opposite of that, kind of thing. Why do I need to do all these? They don't always alternate, okay? They won't always alternate. There will be scenarios, situations, right, where they don't alternate. And so don't assume that they do, okay? And if you maybe have an idea about why they do alternate and why sometimes they don't alternate, well, then maybe you can still do it, right? Maybe you can figure it out kind of thing, but I'm not going to tell you what it is, all right? You can figure it out for yourself. Okay. Let me give you guys one to try here. Let me see if I've got a good one here for you. Here we go. Let me give you. So you guys can try this. X squared plus 4x plus 4 is greater than or equal to 9. Try this one. Let's see, we'll have to try this one. 4x cubed minus 12x squared is greater than 0. And then number 3, we'll have you try x squared plus 2x plus 4 is greater than 0. Okay. Actually, let's make this different, because they're all greater thans. I'm going to make this one a less than. Okay, so that last one's supposed to be a less than. Okay, I know I just made you write that. There you go. Okay, so x squared plus 4x plus 4 greater than or equal to 9. 4x cubed minus 12x squared greater than 0. X squared plus 2x plus 4 less than 0. I know we haven't gone over a cubic here, but I think you can, it's the same principle as what we did with the quadratics. Find your zeros, test your intervals. Oh, question, Ryan.
Yeah, please get it now.
Yes, Ramika.
I have a question about the previous one.
Previous one. Okay, sorry about that. Yes, previous one.
How do you know the direction of the lines, like where it's
So it's a matter of, so you're okay with the fact that when we checked a number, we checked -5 in this interval, right? The interval that was from -4 onward this way. So far so good, right? So since -5 worked, we can assume then that the rest of this entire interval is going to work as well, which includes then the arrow there, right? Because that's part of the interval. Likewise here, this interval worked, and so the entire interval worked, including that arrow part. Okay? So that's the idea. So again, 1, 2, 3, give those a try. If you get stuck or something like that, I'll come around and help. Of course, you can ask a neighbor or something like that, or look off a neighbor's paper if you don't want to ask them. To help, if need be. This kind of analysis that we're doing, by the way, is something that you'll be using later in calculus too, believe it or not. The number line and figuring out where intervals where a function's positive or negative and stuff like that. Same principle you see later in calculus too. In a different context, but same technique. If you take that sense. Meg? Yes. So, does this factor to that? 2 times 2 is 4, but 2x makes
Oh,
4.
jeez, you're right.
2x. That's okay. So I didn't really answer your question, you'll notice when I did that, but
Okay.
what's that? Well, so maybe you can't factor it, but does that mean we can't find any zeros? Did you give that a try? Alright, 30 more seconds or so here. Hopefully you're at least through 1 and 2. Alright, and I'll hopefully give you a chance on number 3 there as well, but. Julia, were you able to answer number 1?
I got, do you want the answer in?
Actually, let's run us through it if you don't mind here. So what did you do first?
So first I set an equation so it's greater than 0, so I moved the 9 to the left side, so I minus it.
Okay, subtract 9 from both sides. You get x squared plus 4x minus 5 is greater than or equal to 0. And then what did you do from here?
I factored it.
Factored it. Great.
So it is x plus 5 and x minus 1.
Okay, beautiful. And so that gives us zeros then at -5 and 1, right? Did you make a number line?
Yes.
Okay, sounds good. All right. At these zeros, is it okay for inequality to be equal to 0?
Yes, but that's okay.
Yep, we want to include them, right? So now we're going to put a solid dot at those points. So we already know 2 solutions, right? 2 places where inequality is equal to 0. But of course, we want to figure out if there's any more places, right? So did you test some numbers in here then?
Yes.
All right, so what did you test here?
I tested -6.
Okay.
And I found
Did you get that interval to work?
Yes.
-6. So -6 plus 5 is a -1. -6 minus 1 is a -7. Negative times a negative is positive. So it looks like, yeah, that interval should work there, right? Okay. And then what you check in here?
0.
0. Great idea. So 0 plus 5, positive. 0 minus 1, negative. Positive times a negative. Negative. Not greater than or equal to 0. So, All right. And then did you test something here?
Yeah.
Good. What did you test there? 2. 2 plus 5, positive. 2 minus 1, positive. Positive times positive, positive. Okay, so there's our solution set, or if you like, as an inequality, x is less than or equal to -5, or x is greater than or equal to 1, right? Good. Questions on the first one there? Easy peasy? All right. Thank you, Julia. Let's go to Matthew. Matthew, for number 2, what'd you do? Did we able to get anything done here? What'd you do, I guess? Tell me what you did. Okay, what is the GCF here? Okay, 4x squared, and that left behind what? X minus 3 is greater than 0. Okay, and then what'd you do? What were zeros from here, I guess? Okay, x equals 3, x equals 0. So on a number line, we'll graph that out here. So 0 and 3. Do we include the 0 and 3 as part of our solution set here? No, right, because we have to be greater than 0, not equal to 0. So we're going to put open circles there at those points. All right, and then you tested some points here, yes? Okay, so -1, let's plug that in, right? -1 squared, 1 times 4, positive. -1 minus 3, negative. Positive times a negative, negative. That's not greater than 0, so Okay, so this one didn't work. How about what'd you test in this interval? A 1? Okay, let's plug in 1. 1 squared is 1 times 4 is 4. 1 minus 3 is negative. Positive times a negative. Still negative. That one didn't work. Okay, Matthew, how about what did you do for the next interval there?
I just did 4.
4, and did that one work?
Yeah.
Yeah, it did. Mr. Wade, why do you make us check every interval? They just alter. Oh, wait a minute. They don't always alternate, right? All right. Anyone care to take or anyone think they have see a link here about why we didn't alternate here? What's that? Because it's 0? Okay, maybe. Megan? Because it's an odd function. Okay, because we have like the cube there or something like that. Odd function. All right. Any other thoughts? Okay, that's fine. I'm not going to say. So, one other thing you could do here, just, graphically speaking, right, if you have your graphing calculator here, minus 12x squared. So let's say we graph this inequality. We'll get to number 3 here in a second. I know you guys are like, Mr. Way, this is just too much. Why? But here we go. Here's the graph of it, right? Here's the graph of this polynomial. 4x cubed minus 12x squared is greater than 0. You can see parts of it are below the x-axis, parts of the graph are above the x-axis. Where does the graph start being above the x-axis? At what x value?
3.
At 3. And values for x beyond 3, right? Our graph is greater than 0 at x equals 3 and beyond. And thus, x, not greater than or equal to 3, Mr. Wade, just greater than 3. There you go. At values greater than 3, our graph is also above the x-axis, which would explain it being greater than 0, right? It's greater than 0, greater than the x-axis, which is y equals 0 there. So you can also see it, right, visually. Right? Same thing here for number 1, right? If you wanted to look at that, x squared plus 4x, I'm going to do the part where it's equal to 0, so minus 5. If we graph that, okay, where is it greater than or equal to 0? For values less than negative 1, 2, 3, 4, 5, or negative 5, sorry, and then values greater than x equals 1, right? For between that negative 5 and 1, you're below the x-axis, so you're less than 0, but then here and here, you're above. Okay? So that's the idea there for our functions. That's what we're doing. All right, last one, number 3. Let's go to Riley. Were you able to come up with anything here for number 3? No, we're not. Okay, so what did you try, if you don't mind me asking? You didn't get to it. Okay, that's fine. We'll go to someone else then. Let's go to Mia Bella. Mia Bella, were you able to come up with anything for number 3?
No.
No? Okay. What did you try? Anything?
I tried the formula.
Oh, you did. Okay, so you tried to factor, I'm guessing, first, right? And you couldn't get to factor. And then you tried the quadratic formula. So let's use that here. So negative 2 plus or minus the square root of b squared. So 4 minus 4 times 1 times 4, so minus 16 all over 2. And what did you run into here with the quadratic formula?
Just once I got down to dividing the 2 out.
Okay.
That's where I started to struggle.
Okay, well, how about here with this 4 minus 16? That's going to be negative, and then we're going to take the square root of a negative. So these roots are going to be imaginary, right? So we have no roots. So if you have a number line, right, we still have a number line, but we have no roots. We have no zeros. So what's our interval here to check? It's the entire number line, right? So in other words here, either everything will work or nothing will work. And so you can pick any number here on your number line because there's no, intervals that we break it up into. There's no real roots. And so you can pick any numbers. Let's pick 0. 0 squared. 0 plus 2 times 0. 0 plus 4. 4. Is 4 less than 0? No. And so the answer for number 3, no solution. Okay? If we graph this, what is the graph? How does the graph kind of show us here that there's no solution? How does the graph show us that this x squared plus 2x plus 4 less than 0, there's no solution to this inequality? What about the graph shows us that? Yeah, so Sydney? Never hits the x-axis. Never goes below the x-axis. Yeah, exactly right. Okay, right idea there. So yeah, that's the idea. Okay. Alternatively, right, if I switch this around and said, when is x squared plus 2x plus 4, when is that greater than 0? Okay. If we said this, when is x squared plus 2x plus 4 greater than 0, what would the answer be here? It's the same inequality, or sorry, same quadratic there, but now greater than 0. When is that true? Always, for every x value. Okay, so those are possible answers here you want to keep in mind, right? When you're thinking about what you're going to solve for and stuff. Okay, questions on any of that? All right. If not, then let me get you guys your assignment here.